Welcome back, everyone, to another Foundry by Forge College Explainer. I'm your host, and first things first, I just want to say a massive congratulations. You successfully finished your capstone build and deploy. Seriously, take a breath, pat yourself on the back, because you absolutely earned it. But don't get too comfortable, because you need to grab your hard hats. We're moving right into our next module, Introduction to Smart Wallet Patterns. Think of this explainer as your master architectural blueprint. We're going to look at the structural designs, the floor plans, and the actual plumbing that controls on-chain accounts. By the end of this, you won't just be looking at smart contracts. You'll be reading them like a seasoned engineer reading a schematic. Let's dive in.
So here is the master schematic for today. We'll start with the smart wallet taxonomy, then move into 5 core wallet patterns. After that, we'll be decoding the Solidity prototype, and we'll wrap things up with the selection workflow.
All right, Section 1, the smart wallet taxonomy. Defining the foundational axis.
Before we start talking about advanced contract logic, we really need to establish a shared vocabulary. Otherwise, it's kind of like a plumber and an electrician trying to argue in 2 entirely different languages. Classifying smart wallets starts by separating 2 absolutely critical architectural axes. First up, where does the authorization live? Are we talking about just a simple private key sitting off-chain, or are there complex on-chain policies dictating who can do what? And second, who actually executes the transaction? Is the owner signing and paying for the gas directly, or is a third-party relayer or bundler executing the whole thing on their behalf? Just keep in mind, every single smart wallet you will ever encounter is really just a different combination of these 2 axes.
Moving on to Section 2, 5 core wallet patterns. Let's examine the floor plans.
We have 5 main families of patterns that you're going to run into all the time. First, key wrapped. This just forwards calls for an owner key. It's super simple, great for low-complexity dApps, but the catch? If you lose that key, you are completely out of luck. Your threat surface is key compromise. Then you have multisig, which requires multiple approvals. Fantastic for managing a massive treasury, but now you have to worry about your signers colluding. You've also got social recovery, session keys, and account abstraction. The big takeaway here is that every single time a structural design solves a specific operational problem, it introduces a completely new threat surface. Let's actually break a few of these down a bit further.
Understanding the nuance between similar ideas is just so crucial. Take multi-sigs versus guardians, for example. On the surface, they both exist to reduce the risk of a single point of failure, right? But mechanically, they are entirely different beasts. Think of it in terms of physical security. A multi-sig is exactly like a daily security checkpoint in an office building. You literally need 2 key cards to open the front door every single day. Guardians, on the other hand, they are like giving your trusted neighbor a spare key to your house. They do absolutely nothing day to day. They remain completely dormant until you trigger a recovery event. Like losing your main keys in a tragic boating accident.
Now, session keys operate a bit differently. Imagine you're playing a fully on-chain game. You definitely do not want to sign a wallet pop-up every single time your character swings a sword. That would be a completely miserable user experience. So, session keys act as a valet key for your crypto. You hand over a temporary, delegated key that can perform very specific limited actions, like swinging a sword or making tiny microtransactions for a short set period of time. You're massively reducing user friction, but you aren't handing the valet the pink slip to your entire vault. And finally, we have the heavyweight of the group, account abstraction. This is where contracts implement advanced account behaviors natively. You get some incredible superpowers here. Think custom gas logic, where a paymaster actually covers the transaction fees for your users. It's magic for onboarding. But remember our rule from earlier, new features mean new threat surfaces. By relying on bundlers and paymasters to handle the execution, you are introducing a whole new operational risk. What happens if that third-party relayer goes offline? Well, your user's wallet is essentially frozen.
Let's move to Section 3. Decoding the Solidity prototype. Time to inspect the plumbing.
Grasping these foundational coding primitives is absolutely essential across all the learning programs we offer here at Forge College. Once you see the matrix in the code, you really can't unsee it. When you peek under the hood of a basic smart wallet contract, you'll typically find 3 main things: an execute function, a session map, and a recover function. The execute function handles your canonical forwarding. It's basically the main pipe that pushes the transaction out. The session map manages the state of those valet keys we just talked about. And the recover function, that's your panic button for the trusted neighbor. It's honestly just so cool to see how abstract human concepts like valet keys and lost key panic translate directly into strict functional Solidity code.
I want you to pay really close attention to the only owner or session modifier. This right here is the authorization gate. This tiny little snippet of logic is what safely permits temporary access. It explicitly separates the long-term authority, meaning the canonical owner who holds all the real power, from the delegated, time-scoped authority of the session key. And the brilliant part is, it does this without ever actually changing the canonical owner in the contract state. It is elegant, it's minimal, and it is highly, highly effective.
Section 4. The Selection Workflow. The Master Builder's Guide.
Okay, real talk. You shouldn't just slap account abstraction onto a project because it sounds cool on Twitter. And all the crypto influencers are talking about it. Which brings us to the single most critical question of this whole explainer. How do you actually choose the right smart wallet pattern for your users? How do you effectively bridge those fluid, easy user journeys with rigid, unforgiving security controls?
Well, you do it by following this reproducible 5-step workflow. First, explicitly state the user goals and constraints. Are they making gaming microtransactions? Or are they securing a $50 million treasury? Second, map out the threat actors. Third, identify the required security properties based on those threats. Fourth, shortlist the plausible patterns from that taxonomy matrix we looked at earlier. And fifth, evaluate the operational trade-offs. And here is my massive warning to you, please do not skip step 5, because every single usability improvement you make will inherently add an operational trust cost somewhere else in the system, for sure.
If you take away literally nothing else from today, I want you to write down this overarching law of smart wallet engineering. Principle number 1. Separate capability from mechanism. What does that actually mean in practice? It means you must always verify that the underlying code, the mechanism, actually enforces the intended feature, the capability. Don't just assume a recovery function is safe to use simply because some developer named it recovery. Read the schematic, trace the plumbing yourself, prove that the mechanism works.
And just like that, it brings our blueprint to a close. For your next lesson, I want you to bring your decision records and your threat mappings because we are diving deep into the core security features within patterns. But before we go, I want to leave you with a final, kind of provocative thought to chew on. If every single convenience in Web3 requires delegating trust to some new mechanism, at what point does a smart wallet stop being truly yours? Think about that. To master more Web3 topics and continue your journey with us, make sure you visit forge.college. I've been your host, keep building, and I will see you in the next explainer.